morning, friends. Today we are going to discuss about the types of flow. That means how we can decide or how we can judge that the flow of a fluid is which type. We have the experience in summer season. Whatever the water flowing in a river, this water is steadily flowing. That means the velocity of the particle at any point of the flow is almost constant with time. So this type of the flow is known as the steady flow. While in same river, in monsoon season, the fluid flood came. So as I said, what's happened? Sometimes the more quantity of the water is flowing, sometimes the less quantity of the water is flowing. Therefore, in this condition, the flow of a water is not steady. So how we can judge which type of the flow of a fluid take place when the fluid is flowing through the pipe or any tube? For that purpose, the scientists named as the REYNOLDS define a dimensionless quantity, which gives, or the value of this number gives the idea whether the flow is turbulent or not. Right? Okay. Therefore, today we are going to discuss about the Reynolds number and also what is the surface tension and surface energy. Okay. Now, Reynolds number, sometimes the 2 marks question is asked, explain the Reynolds number or write short notes on Reynolds number. Reynolds define a dimensionless number whose value gives idea whether the flow is turbulent or not. And this number is known as the Reynolds number, that is denoted by RE. RE is the numerical value. On the basis of this numerical value, we can judge about the type of flow. This number is known as the Reynolds number. The equation of the Reynolds number is RE is equal to rho Vd upon N. What is the rho? Rho is the density of a fluid. V is the velocity of a fluid flowing through the tube or the pipe. D is dimension or the diameter of a tube or the pipe through which the fluid is flowing. And N is the coefficient of viscosity of the fluid. Again, the Reynolds number RE is defined as rho Vd upon N. What is the rho? Rho is the density of the fluid. V is velocity of a fluid. D, diameter of the pipe or the tube through which the fluid is flowing. And N is viscosity of the fluid or the coefficient of viscosity of a fluid. So the flow of a fluid depends on this equation. That is, depends on the density, velocity of a fluid, diameter of a pipe, and coefficient of viscosity of a fluid. As we know this value, we can judge about the type of a fluid. From the value of Reynolds number, types of the flow can be known. If the value of the Reynolds number RE is less than 1000, if the value of Reynolds number RE less than 1000, the flow is streamlined or the steady flow. Steady flow, that means the velocity of the fluid particle at any instant of time is remain constant. That means the velocity of the fluid particle is constant. If the value of the Reynolds number is greater than 2000, the flow is turbulent. If the value of Reynolds number RE is greater than 2000, therefore the flow is turbulent. Now, third is, if the Reynolds number lies between the 1000 and 2000, that means the value of RE is between 1000 and 2000, then flow is unsteady. That means there is a mixed type of flow. Sometimes there is the steady, sometimes the circular form. Right? So this type of the flow is known as the mixed flow. So From this equation, I is equal to rho Vd upon n. Yes, we know the value of rho Vd upon n. We can know the types of fluid. Let us substitute the value of rho Vd upon n in this equation, and value of I is obtained like this, less than 1000. So flow is streamlined or the steady flow or the laminar flow. If the value of I is greater than 2000, so the flow is turbulent, and if the value of I is between the 1000 and 2000, then the flow is unsteady or the mixed flow. Clear this? Okay. Sometimes this portion is also asked the objective question. For a given fluid, the Reynolds number is this. So the type of fluid is clear. So objective question may be asked from this, or the 2 marks question is also asked like this way: explain the Reynolds number or write notes on Reynolds number. Reynolds number is the dimensionless quantity. From the value of Reynolds number, we get the idea the flow is either the turbulent or not. And this number is known as the Reynolds number, and Reynolds number is defined as I is equal to rho Vd upon n. Clear this? Okay. After that, what is the surface tension and surface energy? The energy possessed by the surface is known as the surface energy. How we mention this energy, or how we present or explain this energy, and on the basis of that, how we can know what is the surface tension. We are also familiar that the drop of a water or the rain drop, and also the bubble, air bubble, or the whatever the bubble formed in water, always in circular form. So there is depends on the surface energy. Each and every energy has the tendency to minimize its energy. And due to that result, the circular surface has the minimum energy. And due to that result, the rain drop or the water drop or the air bubble in air or also in water, always in spherical form. The spherical surface has the minimum surface energy. Okay, now we are going to discuss about the surface energy and surface tension. For that purpose, we consider the one example. It's shown in figure. Consider U-shaped pair of a wire, or the format from the wire. Now, the wire PQ slide over the 2 arms AP and BQ without any friction. Right? Again, it's shown in figure. Consider U-shaped pair made from a wire. The wire PQ slide without the friction on both sides AP and BQ. Now this pair is dipped in soap solution of the soap water and taken out. So what's happened? This pair dipped and taken out of the soap solution. Thin film APQB is formed. Right? Figure A shows the equilibrium position of a thin film. So here, whatever the film is formed, APQB has the tendency to contract its surface, and due to that result, the PQ wire has the tendency to move towards the AB. Therefore, we have to apply the proper force on the wire PQ in opposite direction of this force. So as a result, the APQB, this thin film is in equilibrium position. So A is keep in mind that this tendency has to minimize its energy, therefore it has the tendency to contract its surface. And due to that result, we have to apply the proper tension on wire PQ. And this tension or this force is equal to the force applied by the APBQ surface towards the AB. Clear this? Now, in figure B, what's happened? Yes, we apply the slight more applied force, and PQ wire is stretched or the displaced by distance d. That means in figure B, the film is stretched by the distance d. The area of the film increases. That means the area of the surface is now increasing. Instead of the A, P, Q, B, now it becomes the A, P dash, Q dash, B. So in this situation, the system now has the more energy. Means the some work has to be done against the internal force. To expand the surface A, P, Q, B, the final surface is A, P dash, Q dash, B. To expand the surface, the some work has to be done against the internal force. Again, what's happened? In figure B, the wire PQ is stretched by distance D. Right? Since the area of the surface is increases, area of the surface is increases, the system now has the more energy compared to this system. Because the area is increases, therefore the surface energy also increases. Means that the sum work has to be done against the internal force. Suppose the internal force is F and applied force F is slightly more than the internal force. The work done is W is equal to force into displacement. And both are in the same direction, therefore W is equal to vector F dot vector D. That means the F D cos theta, but the force and displacement both are in the same direction, therefore theta is equal to 0, therefore only F D is the work done. That is our equation number 1. Clear this? If the internal force is F and applied external force is slightly more than the internal force, the work done W is equal to vector F dot vector D is equal to F D cos theta, but the theta is 0, therefore cos 0 is 1, therefore W is equal to force into displacement, F into D. Now from the law of conservation of energy, this work done is stored in form of additional energy in the film. How much work done? To expand the surface, this work done is stored as the additional energy in the film. Clear this? Okay. If the surface energy of the film is S per unit area and the extra area or the increase in area is this length is L and that is the D, therefore L into D. But this surface is the two free surfaces. One is front and second is the back side. Therefore, increase in area is 2LD. 2LD. How the increase in area? Delta A is equal to length into width and the film has the two free surfaces. Therefore, delta A is equal to 2LD. Therefore, work done W is equal to surface energy per unit area into increase in surface area. Therefore, W is equal to S into delta A. Therefore, surface tension S is equal to W upon delta A. And also, if we substitute the value of W from equation 1, W is equal to F into D. Delta A, equation 2LD. Therefore, FD upon 2LD, DD cancel, F upon 2L. That is the another form of surface tension. That is the one W is equal to work done per unit area and S is equal to force per unit length of a wire. On the base of this, we are going to define the surface tension. So surface tension is S is equal to work done per unit area and surface tension is equal to force per unit length of a wire. Again, we repeat, explain the surface energy in surface tension. So S1 in figure, consider a U-shaped pen made from a thin wire. The wire PQ slide without the friction on side AP and BQ. Now, this pen dipped in a soft solution and taken out, a thin film APQB is formed. So in figure A thin film is in equilibrium. While in figure B, we applied the slight more external force compared to the internal force. Therefore, wire PQ is staged by distance B. That means the surface of the film is increases. Now, the system has the more energy of the surface. Means that the some work has to be done against the internal force to displace the wire PQ to P dash Q dash. Therefore, work done W is equal to force into displacement. Vector F dot vector D is equal to Ft cos theta. Theta is equal to 0 because the force and displacement both are in same direction. Cos 0, 1. Therefore, W is equal to force into displacement. Okay. From law of congestion of energy, this work done is stored as additional energy in the film. Now, let's assume that if the surface energy of the film is S per unit area and increase in the area is delta A. Delta A is equal to length into width, and the surface has the two free surfaces, or the film has the two free surfaces. Therefore, delta A is equal to 2LD. Therefore, the work done W is equal to surface energy per unit area into increase in surface area. Therefore, W is equal to S into delta A. Therefore, S is equal to W upon delta A. Let us substitute the value of W Fd. S is equal to Fd upon delta A is equal to 2LD. 2LD. Therefore, we obtain F. S is equal to F upon 2L. There is a equation number 3 and there is a equation number 4. So there is the surface energy of the surface tension work done per unit area, and here the surface energy of the surface tension force per unit length of a wire. Clear this? Okay. Now, just with the two equations of the surface tension, S is equal to W upon delta A. There is a equation number 3, and if we substitute the value of W and delta A in this equation, we obtain S is equal to F upon 2F. Equation number 4. Here the S is the magnitude of the surface tension. S is the magnitude of surface tension. Here, S is the magnitude of surface tension. So we can define the surface tension as the surface energy per unit area, or the work done per unit area. That is known as the surface tension. S is the magnitude of surface tension. It is defined as surface energy per unit area. Surface energy. That means the work done per unit area, or the force act on, or the force acting by a fluid per unit length on a movable bar. The force per unit length by the fluid on a movable bar of the wire, that is known as the surface tension. So there is the two definition of the surface tension from this equation. Here the surface tension is the magnitude of surface energy per unit area. Right? Okay. Now listen, from this equation, W is equal to work done per unit area, or the surface energy per unit area, that is known as the surface tension. Second definition is that the force per unit length applied by force per unit length applied by the fluid on a movable bar. Applied by the fluid on a movable bar. Now, SI unit of surface tension is S as the surface unit is force per unit length, that means the Newton per meter, or Joule per meter square from this equation, work done per unit area. Right? Dimensional formula of S. Now Newton M1 L1 T minus 2 upon L1. Right? L1 is cancelled, therefore M1 L0 T minus 2 is the dimensional formula of surface tension. Clear? Already we did this equation. The surface energy or the surface tension is equal to work done per unit area, or it is substitute the value of work done, W is equal to FD, and delta N 2LD, DD cancel, therefore S is equal to F upon 2L. Here S is the magnitude of surface tension. Therefore surface tension is defined as the work done per unit area, or the force per unit length applied by the fluid on a movable bar. That is known as the surface tension. Now the SI unit of the surface tension is from this equation, Newton per meter, here the Joule per meter square. Both equations are same. And therefore the dimensional formula of surface tension, S is equal to dimensional formula of force M1 L1 T minus 2 upon L1. Therefore M1 L0 T minus 2, and from this equation we can add the another SI unit of the surface tension is kg per second square. Kg per second square from the dimensional formula. Clear it? Okay.